Started or no? Let me see. Yeah, the recording has started. Okay, so a recap. This week, so today we'll do logistic regression using codes. On Wednesday, we will do linear regression. On Wednesday, you will have your quiz, which is 15 minutes. Um, 5 multiple choice questions, super easy. Moreover, this weekend you have an assignment submission, which is for predictive modeling. That means you will do a code. It will be very similar to what you're doing on Wednesday. So whatever we will be doing on Wednesday, your assignment is exactly the same. The codes will be the same as well, just that you are explaining whatever answers or output you're getting from those codes. That's the only different part that you will do. The code is the same, you're not creating any code. You will just, so I will explain you how that will happen. I will give you the codes. You will upload those codes on your drive, and that's the codes that you will use for whenever you're doing regression, any type of regression in your life, you're going to use the same code throughout, unless and until the code changes because Python has changed. Other than that, the code is always going to be the same. Okay. Now, today we will start with logistic regression. You can start working on the predictive model if you want, but the class for this model will be on Wednesday. So it will become more clearer on Wednesday. Okay, but you can look at this, you can look at the data set, you can also use the codes from these two linear regressions. So you can start working on it, but it will be much clearer on Wednesday. All right. Okay. So let me open this. Now, you see 4 files here. First, I'm going to start with the mind map. Then we're going to use these 2 files. So this file here, which has, you can see here, it has a IPYNB syntax at the end. This is Python file. So whenever you see IPYNB, this is your Python file with the codes. And this is the CSV file that you will put inside this code. Any questions up till now? Is it clear?
Yes, Professor.
Okay, so I will start with the mind map. Give me a second, please. Okay, so what we're going to do today, as you know, we're going to do logistic regression. But first, before we start, let me give you an introduction about how the codes, what are the codes that we will use and what are the steps. Some of this we have already covered in our previous class. So whenever you're starting a coding, um, or you're trying to create your code, first you need to find what is the problem that you're going to solve using that code. So as you remember, machine learning is solving problems, right? You're learning from the data and you're solving a problem. So what is this problem that you're going to solve using your code or machine learning? So what is that problem? In our case, what we're going to do is we're doing logistic regression. In this logistic regression, if you remember logistic regression, it is always having independent variables and dependent variables, but the dependent variable is categorical. It's ones and zeros. So this is our data set for logistic regression. These two will be our independent variables, but our status is our dependent variable, but you can see it's categorical because it has zeros and ones. So in logistic, whenever you have to find or whenever your y is categorical, you're doing logistic regression. So that's why we're doing logistic regression. So what is the problem that we're solving? We're trying to solve, so a zero is that the customer will buy and one is the customer will not buy. Just an example. So the problem that we're solving is, will the customer buy or will the customer not buy? Okay, so that's the problem that we're solving. We're trying to predict if the customer is going to buy something or they're not going to buy something. And how are we going to predict this? we're going to predict using age and salary. So based on these two independent variables, we're going to predict if the customer is going to buy the product or not buy the product. Do you understand what is happening up till here? Any questions? Is
Understand.
it clear?
But yes, it's clear.
Okay. Now the next step is that we will collect data. In real life, we don't, no one is going to give us the data set. So the next step after finding what problem we're going to solve, we're going to collect the data for that problem. So here in our data set, we collected age, salary, and if the customer is purchasing or not purchasing. So we're going to collect this data. After collecting the data, now these are the steps in our code as well. So if I will be showing you the code, you will first put your data set. After that, you will be summarizing your data set. That means you want to see how many rows are there in the data set, how many columns are there in the data set. Uh, Maybe you want to see the first 5 rows of your data set. So the third step would be that you're summarizing your data set. So for this, you will be using these three codes. So the first code will be you're loading your Excel file. You're telling the program to read that Excel file. Then you will put the code where you will tell um, the Python file that you need to know the number of rows and columns. And then if you want to know the 5 rows of the data set, you will put this code. So I will show you the code and you will see that this exact same thing we're going to put in our codes. These are the codes that you will put for each subsequent query. So here you're loading the data set. So this is the code. Here you have you need to know the rows and columns. So this is the code. Here you need the first 5 rows of your data set. So this is the code. Okay. So that's our third step. Now I don't want to, I can show you this in another code. 1 second. Let me open my Google Drive. Let me show you this one. So this is linear regression, but you will see that after loading our Excel file, then we do that PD read CSV where we're asking the program to read the Excel file. Then we're asking the shape of the data set. That means the rows and the columns. So these are the number of rows. These are the number of columns. Okay. Then the next code is we're asking the program to give the 5 topmost rows of the data set. So these are our 5 rows. Okay. So these are, so our third step. So first, after importing the libraries, after putting the Excel file, after asking the file to read that Excel file, then we're going to summarize the Excel file. Okay. Now our next step. Now the Python file does not know, or the Python software does not know that in these 3 columns or in these 3 variables, which one is X and which one is Y. So our next step will be to tell the Python file that this is our X and this is our Y. Clear? So here we are going to tell the Python file that our X is this and our Y is this. Now this needs some explanation. So look very carefully. This is a command. iloc in Python is a command where you're selecting whenever you want to select values um, in a particular row and column, you're going to use iloc function. Now, what is this in the bracket? The one in the bracket is that it's telling you Guys, please remind me to mark your attendance at the end of the class, okay? Now, what is there in the bracket? You see that semicolon? Semicolon means that select everything from the beginning. So you're telling Python that select everything from the beginning. So that semicolon means start from the source. So this is the source. So select everything from the beginning. Then that two dots source minus one means that don't take the last column. So minus one means minus one is the last column. Okay. Source minus one means that leave from the source, leave the last column. Okay. So it will only select A and B. That's it. So it will only select age and salary. It won't select the last column from the file. That is for X because these two are our X and this is our Y. So age and salary is our X, status is our Y. So we're telling the program that forget the last column and only select these two columns. So that is what is happening in our code. So we're taking this from the source, but we're putting source minus one, meaning that forget from the source, forget minus one, the last column. Okay, so that is what it is saying. It is start, where are you starting from, and where are you ending your column. Okay, now here you have the source, but then here you do not have the start column. You are only taking the end column, which is minus one. So you're not taking the source, you're only taking the end column, which is your status. So here you're only selecting the last column. So that's why you don't have the source from there. Do you understand this? Do you understand this code? Is this clear?
Yes, Professor.
Okay. Now, there's another way. Majority of the coding places show this, but I can show you something simpler. Okay. So, second. So here I did the same thing for X, as you can see. Okay. Here I did the same code. After doing the same code, then I set what is the shape now. So it selected only three columns. Okay, it did not select the fourth column, which is our Y. Now, what I will do is I will show you something simpler. Instead of putting this code, what I did is in the data set, I put two brackets and then I named the columns. So I put hours, age, and internet. And then I started printing X, and this is what I got. So if you look at this, and if you look at this, the values are the same. It will select the same thing. Just that here I am telling them to take the values and not take the minus, the last column. Here I am naming those columns that I want to be selected. So if you look at this, I put the minus one. These are my values. Okay. But I can also do this, that instead of asking them to take the values, I can ask them to take that row itself. So if you see 780, 78.5 and here also 78.5, it's the same thing, just that two ways of getting those values. Does that make sense? Is this clear? So these are the two ways that you can use. You can use this code or you can use this. But you have to make sure that there are two brackets here, because this bracket is for the marks and this bracket is for the data set. So you have to use two brackets. If you use only one bracket, it will give you an error. So you need to put two brackets and it will select the same column as this code. Guys, if you have questions, please stop me and you can ask, okay? Now, we're done with X and Y. We're done with segregating the data set into X and Y. Now we need to split the data set into training and testing. So if you remember, in our last class, I told you that one of our stage in machine learning is that we train half of the values and we test half of the values. Not half, but let's say training would be 70% and testing would be 30%. So that you need to tell the Python program that we're splitting the data set now into training and testing. But that will happen randomly. Okay. We need to do that to understand if our model is performing well or not. So this is the code for training and testing. Okay. I will show you this in our Python program. So if you see here, we're telling the program that we're going to split the training and testing data. We need the x's, we need the y's. So before this step, we have already defined x and y. So we're telling the program we need all the x's and all the y's. And then you're telling the program that our testing size or our testing data should be 25% of the data. So from this entire data set, Python will automatically, or the machine learning algorithm will automatically, right up till now, we haven't applied the machine learning algorithm. So right now, Python is working and it's saying that automatically once you run this code, it will divide the data set into 25% testing and 75% training. Okay. And this random state means that you are not fixing the selection of the variables, it's a random. So that's why we're putting a 0. Is this clear? Any questions regarding the data set split?
Prof.
Yes.
So it means you're testing 75%
No,
of the
you're
whole data
training
set?
75%.
Sorry. Yeah, training
Okay.
75 and testing 25%.
25.
Yeah.
Exactly.
I just didn't
Now,
understand the random state.
random
Of,
state is you are not going to, so if you remember probability, we select
mhm.
items in random or we select in a systematic format. Here, we're telling the Python language that you need to select the values in a random format. There is no systematic way. So that's why you're putting random state as 0.
Okay, so it doesn't have to do anything with the coding of ones and zeros right now?
No,
Okay,
no.
great. Thank you.
Now, the next step is feature scaling. Now, if you look at our data set, age is very small and salary is too big, meaning these two scales are very different from each other. And we're trying to, um, so what happens, or Python language, what it will do is the biggest value, it will give more importance to that value. So even if both of these values are important in our analysis, Python automatically what it does is it gives more attention to the one that has bigger numbers. So thinking why? Because it considers that the scale of both the variables are the same. So age is having similar scale to salary, but they're not similar. Age is based on years and salary is based on dollars or a money amount. So we need to do, or we need to tell the program that the scales are different, but we have to bring these scales to an equal level. So we do something called feature scaling. Now, if you look at this table here, we have weight and we have price. Now, weight is 15, but price is 1. Python language will automatically, what it will do is it will consider weight because weight has more magnitude, it has more value as compared to price. So we need to balance this bias that is being created. So this importance that is given to weight because of its size, we need to balance that. And we're going to use feature scaling for that. Now, there are two types of feature scaling: standardization and normalization. If you wanted to do this in formula format, you would have done these two ways. But if you want to do this in coding format, there is a simple code and I will show you that in the Python language. But what is the difference? What you're doing in this is that you're taking both the variables and you're comparing it with the mean values and standard deviation values. And based on that, you're actually creating your, so instead of having These numbers, you will have something that is more closer to each other with similar scales, because you're comparing it with the mean and standard deviation, and you're trying to find something that is closer to the mean. So both the values will come closer, and it will be easier for you to compare between these values. This is done. This is just for your understanding. This is done through a very simple code, and I will show you that. But this is why we do feature scaling. Any questions regarding feature scaling? Questions. Then you select the algorithm. So after your feature scaling, after you are done, now this is where your machine learning starts. So here is where you would select your algorithm, and in our algorithm, since it's categorical variable, we're using logistic regression. Then we're going to train the data set. So the data set to train is only 75%. 75% will be removed. This is the code where you're telling, okay, now the model should train X and should train Y. Okay, so this is the training. After that, once we're done with the training, we are trying to find, or we're trying to evaluate the model, and we're trying to see how accurate this model is. And for this, we use something called confusion matrix. This is very important. So for this, we use something called confusion matrix. And what this tells you, for example, there are 4 sides to this confusion matrix. Now, this one that you see, false negative and false positive, in probability or in statistical, this is type 1 error and type 2 error. Okay. Now, in confusion matrix, we don't call them type 1 and type 2. We call them false positive and false negative. Now, what does this mean? True positive means that, for example, so let's say this one is customer will buy. And our one is customer will not buy. I'm just giving you an example right now. Okay. Now, so this is a positive value, right? And 1 second, guys. Let me zoom this a bit. Okay, this is a positive value. This is a, what is happening? Okay, this is a positive value. This is a negative value, right? Customer will buy, customer will not buy. When the program correctly finds the positive value, that means correctly finds the 0 value, this is true positive. Meaning, this is a positive value, customer will buy, and the program correctly predicts that this is customer will buy. So this is called true positive, meaning the program correctly found this positive value. True negative is that the program will correctly find that this is a negative value. So it will correctly find, or it will truly find that this is a 1. Okay, this is true negative. Is true positive and true negative clear?
Yes, clear.
Yes,
Okay.
Yes, but
Now, what is false positive? Now, here you should have let me remove this. Okay, let me remove the true positive as well. Okay. Now, what is false positive? So it will be, for example, it is customer will buy, but we, or the program tells you that this is not customer will buy, this is customer will not buy. So it will, instead of 0, it will put 1. It is predicting wrongly, and it will tell you false, a false positive. So in another way, let's say our positive is let's say this was actually a negative. Customer will not buy. Okay. And it should be a 1. But our program says that customer will buy. It is a 0. It predicts wrongly. This is false positive. It is telling you a false positive value. It's telling you a wrong positive value. On the other hand, false negative is that it should be positive, but the program is telling you a false negative value. It is telling you a 1 instead of 0. So instead of this 1, let's say you have a 0. This is a false positive. Instead of 0, you have a 1. This is a false negative. Does that make sense? Any questions? So you don't need to know what is a false positive or a false negative, or how will you understand if this is a false positive or false negative. What you need to actually understand is, one second guys, where did the mind map go? You need to understand this. So in your program, you will get something like this. In the Python page, you will get something like this. So you need to understand, and you will get numbers. So you need to understand, okay, this is true positive, this is false negative, this is false positive, and this is true negative. So that's when you will understand, or you will know that this is what the confusion matrix is telling you about the model. So for example, your actual value should be negative, but the program predicts that it's a positive. This is false positive. Okay. Now here, if you look, the actual value should be positive, but the program tells you or predicts that the value is negative. So this is false negative. So this box you need to understand, and then you can make sense out of the confusion matrix. So this is how you will evaluate the model. It will the answer in the bottom of the confusion matrix will tell you how successful your model was. Then the last step is, now once your model is successful, now you're going to predict using new data. Okay, so this is the formula, or the code for prediction. Now I will show you this entire thing on the code one by one, okay, and then it will make sense. Okay. Here is week 8. And so download the folder first. Now this is our data set. This is what we need, our data set. And this is our Python file. Now what will I do with my Python file? I will go to my Google Drive. Okay. I will go to my Google Drive. I will go to the folder where everything is saved. I will upload this Python file on my Google Drive. So I will go. So let's say this is my drive. I will go to my notebooks, my Colab notebooks, and then I will upload this. So how will I upload? New file upload. Now, wherever you saved your folder from the course page, wherever you download the folder, from there, select that file. So it will look something like this when you download it. The first one that you see, add sale prediction, that's what you're going to upload. Okay. Please do not do this right now. I will give you time to do it. But for now, do not do it. Just listen. Now, once you upload that file, you will see that it's uploaded, and you will see the file here. This is the file that you are going to work on. Now, let me double click and open this file. So this is how your Python looks like. Now you can see here. Says day 3. It should be day 2. I will change that. Anyways, actually it is date 3. Now, first step, as I had explained in last class, is first step is you need to import your libraries. So the Python language cannot read the data set, cannot use mathematical operations, cannot use machine learning algorithms unless and until you don't add libraries to the program. So you need to import those libraries. So you're importing pandas as PD. So you're importing that library. This library is going to read your data set or your Excel file. And then you're going to import numpy as np, and this is going to read other values in your Excel file. Okay, numpy is also necessary for some mathematical operations as well. But there is another library called sklearn. Sklearn, this is where your machine learning algorithms are coming from this library. Okay, sklearn library. Now once you have done the libraries, then you're going to import the data set. So let me run this. I will run this. It will give me a tick mark. Come on. So the libraries have been imported. Now I will do the next one. So instead of clicking the play button, you can also do Control Enter or Shift Enter, and it will run. Now you see this code is asking us to upload the data file that you want Python to read. So this is the data file that I want Python to work on. Okay. Oh, I should delete all this. Or maybe don't save. Okay, so that is the data file I wanted to read. So I will go and select that file. So if you can see, this is the data set that I want. It should be, make sure it's a CSV file. So if you go here, you will see that Microsoft comma separated value. So it's a CSV file. I'm going to select this and add it over here. Now, one thing that is very important, your data set has been uploaded. One thing that is very important, make sure that this uh, Excel file name and this here should be the same. Now you're loading the data set and you're asking the pandas library, so PD, you're asking PD to read your CSV file. But it cannot read it, and you will see if I do this, it will give me an error, file not found, because the file name is different. So I'm going to copy paste and put this file over there. So I'm going to put this file over here. Okay, now let me run this and you will see that it has a tick mark now. So it has read the Excel file. Now I'm asking the Excel file, the Python language, to first look at the data set and tell me the shape of the data set. Tell me the rows, tell me the columns. Then after you tell me the rows and the columns, I want the data set to give me first five rows from that data set. So it's saying print data set shape, then print data set head, meaning the first five rows of your file. So I'm going to do that, and you can see this is the number of rows. So we have 400 rows and 3 columns. So if you remember, the 3 columns were age, salary, and status. So 400 rows, 3 columns, and these are our 5 values. Okay. Is it clear up till here?
Yes, Professor.
Okay. Now the next step is we're segregating the X and the Y. So we're segregating the independent variable and the dependent variables. In this, we're going to use that code. But if you remember, we're taking source -1 to remove that status column. Okay. The other way you can do this is you can take X is equal to data set, put bracket, and then put age. Okay, I can do that 1 second. I can add a code cell here. Okay, X is equal to data set. Then you put 2 brackets, and this will be age and comma salary. Okay. I might have done some mistake. New word. Probably I forgot. It should work. Maybe I forgot. Oh, the full stop there. Oh, I put the right code. It should work. Maybe because it's not in an array format, that's why. It should work, but I probably it's not in an array format, that's why it's not.
Professor, it's capital A in the age and capital S in the salary. If you put that, so it's working.
Yes, yes, you're right. Yes. So the age and salary, and you can do that, or you have to do here. Okay, these two are the two methods to get age and salary. If let me minimize this, it's become a long list. So let me remove this and this. Now you can do the same here as well. You can do either this or you can use another code. Let me add a code there, and you can do data set bracket, and this is status, and then y, and it will give you the same thing. Okay, so these are the two ways to do it. Now after we're done segregating the data, then okay, I'm going to remove this because we already have the first one. I don't want the code, but you understand the idea. Okay, so I will remove these two and keep those two. Okay, now my next step is splitting the data. So whenever you want to get anything for machine learning, you're always going to use the sklearn library. So here also, if you see sklearn, here also sklearn, here also logistic regression, sklearn, everything is coming from sklearn. Okay, so from the sklearn, so this is the code that is used for everything. From the sklearn model selection library, you're going to import the train test split algorithm. So you're importing that. Now you don't need to memorize these codes. All of these codes are available online. Okay. The only thing, some of the things you might have to change based on your model. But is this code similar throughout? Yes. Now you're telling the model that split the data set in this. So you will have 4 data sets. One will be the X train data set, the other will be the X test data set, then you will have Y train data set and Y test data set. You're telling that these are our 4 data sets that I want you to, you're telling Python language to split it into these 4. Now you're telling this is the code that you're applying. So you're saying split it into X and Y, then split it into train and test. So first you will split into X and Y, then you will split into train and test. And your test should be 25% and it should be in a random state. It should be done randomly. Once you enter that, the Python language will has done the split. Next step is our feature selection. And in our feature selection, to have equal weights, we have standardization and we have normalization. So here, majority of the time, we always use standardization because if you look at normalization, the formula for normalization, you will see that they're using minimum and maximum to get closer to the range. Sometimes if we have outliers, it might not work. So that's why we always stick to standardization rather than normalization. Okay. This is the code for standardization. Now you're getting from the sklearn library, you're doing pre-processing. So if you remember data cleaning and if you remember you're removing missing values, duplicate values, you're making the data more scaled. All that is coming from pre-processing. And in this, you're importing standard scalar. Okay, now what I'm doing here is, since I don't want to type this again and again, I will make this short into SC. And in my other codes forward, I will only, instead of putting standard scalar and the entire word, I will only put SC. Now, for train and test, both will have different formula. For train, you will have fit before the transform. In test, you won't have that fit. And why is that? Is because you don't want the algorithm or the system or the machine to have to see your test data. So what is happening in training? It is taking every value. That means it's taking age and scaling it first. Then it's taking salary, it's scaling it. Then it's taking status, scaling it. It's taking the values one by one and scaling it, or doing the mean and variance one by one. In test, what happens is it takes all the features together. It takes age, salary, and status all together and then does the scaling all together. And why is that being done? It's being done so that the model does not see the data and it's something new and surprising for the data. Does that make sense? That's why we have two different formulas or two different codes. Any questions, guys? Any questions, guys?
No, Professor.
Okay. Now we're doing the logistic regression. Now we're doing the training. So here again, from the scalar, we are taking the linear model and we're importing the logistic regression module. In this, we're telling that your logistic regression should be random. For what you're doing the logistic regression, you're doing the logistic regression for the X train and the Y train. You will not do it for the test because test is unknown. So you will only take the training variables. Now, once you're done with training, now is the prediction part. Okay, so this code is a bit complicated, but it's easy to understand if you look at it carefully. So we're creating something where the customer or you can input new data. So we're saying that your age should be, whenever you want to enter new customer age, it should be inputted as, and so you will put a value in enter new customer age. So in this dialog box, you will put a value that will be your age. Then if you're putting a salary, that will be your salary. Once those values are input by the customer, so you are saying input. So let's say once you put those new values, that will be considered as a new customer. So once those values are input, it is considered as a new customer. After it's been considered as a new customer, then it's going in prediction. It is going to tell you if using this age and salary, is this customer going to buy or is this customer not going to buy? Now let me show you how this works. So play, let's run this as well. Now, once I run this, it will ask me my customer age. So let's say it's 45. Okay. Then I press enter, it will ask me customer salary. So that will be, let's say 30,000. Okay, let me press enter. It says customer won't buy. Okay, so this is what is happening. Once we're inputting these values, we input these values, this becomes our new customer. Then the model predicts if this new customer is going to buy or won't buy. If it's going to not buy, it will be 0. That means else print. So if it's not, if the result is 1, print customer will buy. If the result is not 1, that means it's 0, you need to print that customer won't buy. Do you understand this code? Does this make sense? Guys, are you all sleeping?
Prof, how
I
is
guess
it
we are
different?
lost.
Professor?
Exactly, I knew it. Yeah.
How is it different from the one that we had in the status where it's 0 that the customer will buy
So
and
this
1 will
is
not
for
buy?
new data. So this is not for previous data. This is for new data. This
Mm.
data you have not seen before. How is it different? What is happening now? Once you're done with training, now the program knows that, okay, if we get 35 and we get 20,000, it's always going to be a zero, or always going to be customer is going to buy. It has already learned from that model during that training. Now, when you put new data, it's going to tell you if the customer is going to buy it or not going to buy it. So this is where you're testing the model. Do you understand? Or you're creating those predictions. So you're seeing now if that training, whatever has happened, is working or not. Clear?
Here.
Any other questions? No questions? You should have questions. Okay. Now, this is our prediction. We created a predicting code. Now, next one, once we're done with our training, now we're going to try it on our testing data, the remaining. So we're going to say, we're going to predict Y using the X test. Okay. So the 25 that is there, those zeros and ones we're not taking. As you can see in the code, Y test is not taken. Y test is kept on the side. We are only taking X test to predict Y. Now, why are we doing this? Is whatever answers we're going to get in prediction, then we're going to compare with the Y test. So we will compare the two and see if our model did the correct answers or not. So Y test already has zeros and ones in the status, but Y predict does not have zeros and ones. So whatever we get in Y predict, we're going to compare with Y test. So if our Y test is 0 and our Y predict is 0 as well, okay, our model is working well. But let's say if our Y is 1 and Y test is 1 and our Y predict is 0, then our model is not accurate. So that's what we're seeing. We're predicting, and now we need to compare with the test and see if that model is working perfectly or not. How are we going to know this? Through confusion matrix. So this is our, let me run this 1 second. What happened? Current and P concatenate. Length Y predict should be 1. That's correct. Yeah, look into this. Why this is giving me no attribute reshape? Oh my god, the code has changed. Mhm. The code has changed. I will have to fix this with another code. Okay, I will fix this later and upload the new code. Then we're going to have confusion matrix, and in this we're going to, so you can see once we have the confusion matrix, in this we're going to find out how our model is doing. So this is our true positive, this is our true negative, this is our false positive, this is our false negative. So this is our confusion matrix, and see our majority, you can see that we don't have any false positive, we don't have any type 1 error, we do have some type 2 error there. Okay, but majority of our values have been considered as, you can say, it's been taken as true values. So majority of our data is being considered correctly, it's been correctly segregated or classified or predicted. So that's why our accuracy of our model is 80%, as you can see here. Now this is the code for that. What we're doing is we're taking we're taking the confusion matrix, and we need to find the accuracy score. So if you import confusion matrix and you don't import accuracy score, you won't get this 80%. So you need to import accuracy score. Now you need to compare. So like I said, we're comparing the test and the prediction. Okay, then we're telling print the confusion matrix and print the accuracy of the model. That's how we want to see what is happening. So that's the code, how you print it. Okay, you have to tell the program what kind of output you want. This code will be used for any data set. You can use the same code. I will look into this code now, but this is the code that you will have for every data set, and it will not change. Okay, your X, your Y, everything will be the same unless and until Python changes something. So for example, I have an error here. I will see what it is right now. Reshape. There is a code for reshape and the array. Instead of concatenate, maybe I want to use end the array. Okay, I will check this later. But right now I want you to do it. It works fine when you run the code. Let me try then why it's not running. Maybe oh, customer age 1000, really? What are you doing? Customer will buy. Then I need to run this. Why this is giving me an error? Did I delete something from the code or what? The code is there. Will return object dot. Okay, let me run the entire thing once more. This is done. Let's put Oh, now it's working. What? Okay, now it's working and the confusion matrix is working as well. Okay. Any questions regarding the coding part? Now,
No, Professor.
yes. I can't hear you. Someone said professor and then muted themselves.
Yeah, that's me. I said no, Professor, no doubts.
Okay, okay, done. Um, all right. So now I want you to do this by yourself and understand we still have about 40 minutes. So go to your course page, download the folder, upload in your Google Drive. Um, Try to run it, press Shift Enter every time you want to run a cell. Change this CSV file. Understand each code. When you're stuck and you don't understand any item, let me know so I can explain you what it means. You will be doing this for your predictive model, so you need to understand each and everything. The code will be the same, but you will be changing a few things. So for example, you can change the test percentage. So maybe you can make this 30. Or maybe your columns, you want something different. You can change that as well. Maybe in the data set. So in your predictive model, as I remember, in your predictive model, I have a big data set that I have given you, and you're going to choose what you want to predict, what are your independent values, you're going to choose. Okay, so this is the data set, and in that data set, you have different items. You can choose um, what you want to take as your x and what you want to take as your y. Okay, based on that you will choose your regression. So for example, if you want to, there is something called sales price. If I want, let me see, here somewhere there is a sales price, if I remember. Yeah, so year sold, sale type, sales price. So let's say I want my sales price to be Y, and maybe I can choose other variables like year, maybe I can uh, do month sold, maybe I can do I can change this to zeros and ones and take this as my X. So you can choose and then you can specify the column names in your code. So instead of using this code, you can do X is equal to data set, bracket, bracket, and then put the column names as your X. For Y, do the same. And then keep doing the same steps. So the formula is going to be the same, just that your code, few things in your code, for example, the CSV file will change. You can change the head. Uh, you can change this to the name of the columns. You can change the size. Um, yeah, rest everything is the same. Here you can change the result if you want, but this is only for logistic regression. If you're doing linear regression, then you wouldn't. I want make sure it's linear. Linear is easier. So don't do logistic regression. You will have problems while you are creating this. Even in this, you just have to change a few things here and there. That's it. Um, then this is going to be the same. And this is going to be the same as well. So you're not changing anything, just a few things in the code. Okay. All right. So guys, practice right now. I will mute this so that you can use it. And you can ask me questions if you're stuck somewhere.